When you're working with a formula like this, the formula is usually given to you in a fashion such that it is prepared to have any number of variables placed into it. For example, with this formula, the way it's sitting right now, you should plug in a P, plug in an R, and plug in a T, and when you multiply, you'll know what your interest is. But sometimes you need to be able to solve for something besides the variable that is already isolated. For example, let's say we wanted to come up with a brand new formula, one where you don't plug in P, R, and T and find I. Let's say we wanted to be able to plug in I and P and T and find the rate. What we're basically being asked to do is to solve the simple interest formula for the R value. Again, so that you can repeatedly plug in I, P, and T and have R already solved for, so you can immediately get it right out of the formula. Now what you need to do when you're solving for a variable within a formula like this is treat the other variables the same way you would a constant. In other words, as soon as I'm told to solve for R, I'm going to look at the I, look at the P, look at the T, and treat them just like constants. So the first thing you might want to do is change sides. In other words, make a left hand, right hand switch so the variable, which for us now is the R and only the R, is on the left hand side. We see that there is a P and a T on the left hand side we don't want. They are being multiplied by R. So to get rid of them, I will simply divide both sides by P and T. The P will cancel the P, the T will cancel the T, and you have R equaling I over P times T. So I could, if I wanted to, take an interest, a principal, and a time, plug them into this newly created formula, and it would immediately give me the rate. So let's try that again. Let's say we had A equals 1/2 times B times H. You might recognize that as the area formula for a triangle. But if you're asked to solve this for H, what that means is we want a formula where we can plug in A and plug in the B and have H. So what we want to do is, in this case, first of all, we have this 1/2 we might want to get rid of. We will do that by multiplying both sides by 2. So now the fraction's gone. And being able to work with something other than fractions is going to make it a little bit easier. Again, I think I'll switch left hand side and exchange it with right hand side. So now that the variable I'm solving for is over here on the left hand side, I can now divide off that B, and you have H equaling 2 times A over B. And again, you're going to have to get used to having answers that have variables within them. That is the norm for this type of problem. So you just have to get used to that a correct answer is an answer where you're solving for a variable with variables in the final answer. All right, let's try another one. Let's take AX plus BY equal to C. Now, as this is written right now, C is solved for. But again, we could choose to solve for anything else that we want to solve for. I could solve for A, or X, or B, or C. Let's say we want to solve for A. I will first subtract off the BY, because remember your subtraction, your addition and subtraction comes before any multiplication or division when you're solving. The last step is going to be to divide off the X that you don't want, and you have A equaling C minus BY over X. Again, an answer, yes, with variables in it, and that's something you just have to get accustomed to. Now if you run into a problem, again with a fraction in it, especially a fraction that has a binomial, trinomial, or something complicated on top, you're going to first want to get rid of that fraction. So I really am going to look at this and not worry about so much what I want to solve for. I'm going to first worry about getting rid of that fraction. Multiplying both sides by 3, the fraction cancels. And now we can think about what we want to solve for. If we wanted to solve for the b, I could subtract off the small a, and bear in mind that an uppercase a and a lowercase a are going to be considered different, therefore not like terms. Now I will subtract off the c, and you're going to get b equaling 3 uppercase a minus lowercase a minus c. And notice I didn't switch sides until the very end there. So that means it's optional. You can switch sides if you want to, but that's not actually mandatory. Let's do one more. Let's take a 3x minus 2y equaling 5, and let's solve that for the y. Okay? You don't want to divide off first. Remember, when you're solving an equation, use your addition property before your multiplication property. So I will subtract off the 3x. Now you could write this as 5 minus 3x. I like to see my variables up front and my constants afterwards, so I'm going to write that in my preferred order. You're going to divide off the negative 2, and you end up with y equaling negative 3x plus 5 over negative 2. And you could choose to separate that negative 2 into a negative 3x over negative 2 plus 5 over negative 2, which simplifies to 3 halves x minus 5 halves. So again, this was an acceptable answer, but if you choose to, you can break it up and give your answer in this other form. So basically, when you're solving a formula for an indicated variable, you treat that variable like it is the only variable. You treat all other variables as if they are constants, and you're going to look for an answer with variables inside of it.